Okay, welcome back. Now this section here today on dividing complex numbers is just for the honors algebra 2 students. Okay? So if you're not in honors algebra 2, you don't have to go through this video. If you are in honors algebra 2, then it's a must that you go through this video because it will be on your exit tickets, on your practice, and this will be on your quizzes or your test. So remember, we've got the same thing, I squared equals -1, because we're going to have to apply that in today's video. So there's something called a complex conjugate because you cannot leave an I in the denominator. It's kind of like the whole can't divide by 0 thing, undefined, or it's irrational, or it's just not proper in your complex number system. So I have to get rid of the i's in the denominator. So to do that, you're going to have to multiply it by the complex conjugate. Now the complex conjugate, if you take your denominator and you just switch the sign that separates the real and the imaginary part, so if I just do 2 minus 3i, that's going to be my complex conjugate. So let's just go across these. So if this one's 3 minus 4i, it's going to be 3 plus 4i. And then the last one is just I. That one's going to be -i. So notice we're always changing the imaginary part, the sign is kind of in front of that. Okay, so let's get started here. These are just kind of time-consuming, tedious work here. Basically what I'm going to do is multiply the top and bottom of this fraction by the conjugate, so the 2 minus 3i, and then I have to do a whole bunch of foiling. So I'm going to FOIL the numerator, then I'm going to FOIL the denominator, and start simplifying. Okay. Now, just like we did in this previous lesson right up here, you can kind of see a little bit of it. We're going to cross out the I squareds, and we're going to change the sign of the number that it's attached to. So, for example, this is going to become a minus, and this one's going to become a plus. I mean, that's all it does to the problem. So it makes it a real part, though. It's now a real -15 and a real 9. So when we combine like terms, 8 minus 15 is -7, and then minus 22i all over. Now the 6 i's are going to cancel. That's what we wanted to happen, and that's the whole purpose of doing the conjugate, is because those will always cancel. And then 4 plus 9 is 13. Now I am going to break this apart, so I have a real part and an imaginary part. So that's my final answer. So you just got to be careful, along the way here, so you don't make a little sign error that kind of throws you off. Very easy to do. Okay, same thing on number 14. I'm going to multiply top and bottom by its conjugate, which is 3 plus 4i. And I'm going to have to FOIL again. Okay. So let's take care of those I squareds first. So get those out of there. This is going to become a -4, and this will be a plus 16. They just go to their opposite. Now you want to combine your real parts and your imaginary parts. So 3 minus 4 is -1 plus 7i. And the 12 i's cancel. If you ever have i's left in the denominator, then you probably made a mistake somewhere. So you need to look back through because those i's should always cancel. And that'll be 25. And now I'm going to break it into the real part and the imaginary part. So it's in standard form. Okay. All right, let's do this last one. So the I have to multiply it by a negative I. So this one's not quite as busy. And I'm going to put that in parentheses. Because this one I just have to distribute. I'm going to work to the right here for now. So as I distribute, I get negative 7i plus 6i squared all over an I times negative I is negative I squared. I'm just going to cancel the I squareds. Now this is just going to become a positive 1. Now I'm going to flip these two around. So that's my real part. And this is my imaginary part. And that's all over 1, but I'm not going to show the 1 because we don't need to. And that's my final answer. All right, see you next time.